Hey everyone, welcome back. Today we are talking about something you do constantly in your code, but probably don't think twice about, which is the equal sign. Most people think assignments are just throwing a value into a variable, like here. And this one is an initialization, not assignment. This one also is an initialization, not an assignment. We are creating these variables out of thin air. And the rule of assignment is the left-hand operand should be a modifiable L-value. And what L-value is, it's just a variable in memory where we can change its value, like our variables here. And here the code check will tell us that this value is an R-value. R-value means it's a temporary value that has no place in memory, a memory address. You cannot assign it. Also here we are adding two variables together and they would result in an R-value. So we cannot assign that R-value to a variable or anything really. Even if it's an R-value, it's not gonna work. It's a random value, like the number 1, 2, 3. They have no place in memory. And finally we have the constant integer, which is an unmodifiable L-value. It is an L-value, but it's unmodifiable, so we cannot use it as a left-hand operand to an assignment if it's a constant. And here we have the correct way of an assignment. And the result would be the variable itself, the left-hand operand, evaluated as an L-value. And because of this, if the types don't match between the left-hand operand and the value, which is this one is a decimal, which means a double, it will convert it to an integer silently. And here, after we print the k and assigning to the decimal, we can see that it has been converted to an integer, which is the number 3. And we can use braces to assign a number to that integer. But in this case, when we are using braces, we can see that there's a red underline because this one would result in an error and your program would not work. So you'll get an error because of using braces, because the compiler detects the narrowing conversion from a double to an integer. So it acts as a safety net for you, so you wouldn't lose any data precision. And for the integers, it can only take one value, so you cannot declare two values for a one integer variable. But if we have a vector inside the brackets, we can declare multiple digits inside it. The standard library vector defines its own implementation of the assignment operator. When we assign these values into that vector, it will wipe out the old data inside it and it will place it with those numbers. And we can use empty braces to just initialize that variable to a default number where the compiler will, in this example, we have an integer, so the compiler will assign the number 0 to the variable. Almost every binary operator you use, like plus, minus, or multiply, is left associative, which means they group from left to right, but the assignment operator is right associative. Looking at this line where we are chaining the assignment together, two variables, because it groups from right to left, first it looks at the right assignment first, which is gval equals 0. And since we know that the assignment returns its left operand, this variable, as its result, so first we assign 0 to the gval, and then it returns the gval, and then gval would become the right hand operand for the next assignment, which is this one. So ival would get the result of the gval, which would become 0. And after running the code, we can see the cout in the console that ival is 0 and gval is 0. For the chained assignment, we should have the same object type. Like here we have an integer, a pointer to an integer, and we have an integer variable. And we cannot use it to assign the number 0 to pval. Even if we can assign the number 0 to the pval, since the assignment, like we said, it's right associative, it assigns the values from right to left. So first it's gonna assign pval to 0, which means it would become a null pointer. And then it would try to assign a pointer to an integer to a normal integer, which would not work. There's no implicit conversion for that, so it would break. And here if we have two string variables and we assign it to a string literal, it would work because the string literal would be converted to into a C++ string for S2, and then S2 would return a string which matches the S1, which is also a string. Let's say we are taking input from the user or getting a certain value, and if we get the number 42, we're not going to enter the while loop. Before the loop starts, we enter a variable, we initialize I to the whatever value we get from that function, and while the number is not equal to 42, we are going to call the function again, copy and paste it here, and assign the value to whatever it returns. It works, but it is repetitive and prone to copy and paste errors. There's a cleaner way to do it, which instead of initializing the variable, we declare it, and then inside the while loop, we can open parentheses and we can say say I equals get value, and that's it. We don't need this line anymore. And now the condition handles everything. It calls the get value and it compares it if it is not equal to 42. And parentheses are essential, so you should have them, otherwise we'll get errors with precedence, because assignment has lower precedence than the not equal to sign. So the compiler will prioritize the not equal first, and then it would basically assign I to either 1, 0 or 1, depending what this comparison, if we remove the parentheses, depending what this comparison would return, we would assign it to I. So if it returns true, which is 1, we would assign I equals 1. If it returns false, it would be I would be 0. So yeah, it would break the whole logic. If we have two variables, I equals 0, j equals 0, and we are comparing them in an if statement, but instead of using the double equal sign, we use just one. The code doesn't break, it only assigns j into I, and then it checks the result. So if j is any non-zero number, it would become true. Otherwise, if it's 0, it's gonna be false. And some compilers will not throw a warning for this. And C++ gives us compound assignment operators, like the plus equals sign. So instead of writing sum equals sum plus value, we can write sum plus equals value. And it's not only a cleaner way of doing it, it actually saves performance, because in this operation we are evaluating sum twice, and in this one it's evaluating only sum once. If the sum is a complex expression, it's gonna save performance if you use this one.